one by one. So first we have to calculate the probability x greater than 43. So first always we have to plot the diagram, right? Based on the diagram, then we have to calculate the probabilities. You also take your table we need, and before that, now we first we know that x be a normal distribution with mean 50 and the standard deviation 4. So it's given that x has a normal distribution. We have to specify two parameters. First parameter is the mean, mu, comma, second parameter, sigma square, that is standard deviation. So variance we have to specify, but this is the usually how we are writing. If x is a normal distribution with mean mu and the standard deviation sigma, then x, it means follows. X follows normal distribution with mean mu and the variance sigma square. This is the way of writing the normal distribution. Right. Now for this distribution, we have to calculate the probability of x greater than 43. Right. So now if we plot the diagram roughly, now it is a x. Now we have a x variable. The center point is mean, that is 50. But we know x greater than 43. So 43 is less than 50. So you have to mark the left hand side. This is 43. Right? Then x greater than 43. So that area greater than 43 is this area. Right? So now the corresponding z value, the boundary points, we have to calculate the z values. So now x is equal to 43 is the boundary point. So what is the corresponding z value, right? So when x is equal to 43, if is equal to 43, z equals x minus mu over sigma. X is 43 minus mu 50 over sigma standard deviation 4. So that is equal to minus 1.75 because minus 7 over 4. So that is equal to minus 1.75. So now this diagram is approximately equal to, so this is equivalent to this is z value. So for the standard normal, it is 0. Now minus 1.75. This point minus 1.75. So this area we need. But in our table, we have a positive values, right? So this is actually equal to, so now we will write it, right? Probability of x greater than 43 is equal to probability of z greater than, instead of 43, when we are writing the standard normal terms, that is minus 1.75. So that is equal to, this area is 0.5. So that is equal to 0.5 plus probability of minus 1.75 less than z less than 0 minus 1 point this area plus this, right? But in the table we have a positive value. So this is actually equal to, because of the symmetrical property, 0 minus 1.75 is equal to plus 1.75, because we know that this standard normal or normal distribution is a symmetrical about the mean. So actually this is equal to 0.5 plus probability of 0 less than z less than 1.75. Now based on the table, 0.5 plus from the table, we have to look at the row 1.7 row and then column 0.05 column. Where this row and column intersect, that will be the probability. That is 0.4599. So that is equal to 0.9599. That is 95.99%, right? 95.99%. So this indicates there is a chance of 95.99% that x being greater than 43. So in the given normal distribution, for x being greater than 43, the probability is 95.99%. Right? So almost minus plus 2 plus 2. Within that we have, so almost 90% of the 95% of the data is covered greater than value 43. 95% of the values are greater than 43. Right? 96, almost 96% of the values are greater than 43. Now second one. If my probabilities are wrong, then you let me know. Right. Now we are coming to what is the probability that x less than 42. So now we have to calculate probability of x less than 42. Right. So now we have to calculate the corresponding z value for 42. This is one of the endpoint. All the values, what is the probability that all the x values are less than 42? That is the meaning. What is the probability that all the values are less than 42 for the given normal distribution with mean, mu, and the standard deviation 4. So for the corresponding boundary points, we have to calculate the probability. So when we are plotting this diagram, this is x. Mean value is 50, then less than 40. We want to calculate this. Right? So if x is equal to 42, z equals x minus mu over sigma. So x is equal to 42 minus mu 50 over sigma 4. Right? So that is equal to minus 2. So now the corresponding standard normal curve, it is z. So it is minus 0. Now we need minus 2. This is minus 2. This area we have to calculate. But this is equal to, this area is equal to, because of symmetrical, because if you have any z values or x values in a negative, now we have to take the positive, symmetrical of positive part, because we have to use the table. In all the table, the z values are positive. So this is equivalent to 0. It is positive 2. So now this left tail area is equal to this right tail area. Right? So now if we come to the corresponding probabilities, probability of x less than 42 equals probability of z less than minus 2. 42 is minus 2, right? So that is equal to, so if we want to get this probability, because we have the probabilities in the table in between 0 to some value, positive value, right? So this is equal to 0.5 minus this area. Now actually we need this area, but from the table only we can get this area. So from the 0.5 minus, if we can subtract this area, then you can get the shaded area, right? 0.5 minus probability of, this is equal to actually probability of z greater than 2. So that is 0.5 minus 0 less than z less than 2. So that is equal to 0.5 minus, from the table, you have to take the row that indicates z value 2, and there is no any decimal points. So the column 0, where the row 2 and the column 0.00 intersecting, that will be the corresponding area, that is 0.4772. 0.4772, that is equal to 0.0228, that is equal to 2.28%, right? So now here we use the point, symmetrical point, and also the half of the probability is 0.5. So two concepts here we are using to calculate the required probability, right? So always when you are getting the negative value, you have to take the symmetrical positive part of that value, right? If it is a minus, less than minus 2, then that is equivalent to greater than 2. In such manner, you have to take the possibilities, right? So now you note this one. Right. Next one, what is the probability? The x values are between 45 to 52. So your required probability is probability of 45 less than x less than 52. Right? So now if you plot this x values, so the corresponding mean value 50, then 52, and 45. This area we have to calculate, right? So now there are two x values, boundary values are there. So for these two boundary values, we have to calculate the z values, right? So if x is equal to 45, then z equals x minus mu over sigma is equal to, now x is 45 minus mu is equal to 50, your mean value 50, and the standard deviation 4. So that is equal to minus 1.25. Right? Then if x equals 52, then z equals, now sorry, x 52 minus 50 over 4, that is equal to 0.5. So now the corresponding, this is equivalent to, with the standard normal variable, so the mean value is 0. So now 0.5 and 45 minus 1.25. So this is the corresponding area we have to calculate. So the two parts here we are adding, this part plus this part, right? So now we are writing the probabilities. Probability of 45 less than x less than 52. So the corresponding, now we are writing in terms of z. So probability of 45 is minus 1.25 less than z less than 0.5. So based on the diagram, one area is 0 to minus 1.5, another area is 0.5. So this one you can separately, probability of minus 1.25 less than z less than 0 plus probability of, we are writing first this area, this left to 0, one area, then right to 0, one area, right? So that is 0 less than z less than 0.5. This one straight away we can get the probability area from the table because it is a positive value, but this is negative value. So here we have to write the symmetrical of this part. So that is equal to probability of 0 less than z less than 1.25 plus probability of 0 less than z less than 0.5. Right? Because we know that this area minus 1.25 is equal to the positive part. To 1.25 by symmetry, right? So now from the table, two probabilities we have to find from the table. That is equal to, this is, you have to get the probability from the row denoted by 1.0 and the column denoted by row 1.2. We have to take the row 1.2 and the column 0.05, where the row 1.2 and the column 0.05 intersected. That is equal to 0.3944 plus, for this one, the row 0.5 and the column 0.00. that is 0.1915. 0.1915. That is equal to 0.5859. Right? So this is the method of calculating the probabilities when a normal distribution is given, right? So based on the normal distribution, now we learned that how we can calculate the probability. So for some cases, straight away you can use the table, but for in some instances, we have to use the rule, symmetrical rule, and also we have to use the rule 0.5 minus or 1 minus something, we have to use it, right? Usually 0.5 minus. Now we want to calculate the probability is given here, but we have to calculate the corresponding x values, the same distribution normal with mean 50 and the standard deviation 4. Right? So now first we mark the probability. 5% of the values are less than what x values. Right? Now here the main thing, right, appropriately you have to mark the area. If you are marking the area is wrong, then you can't get the right x values, right? So now this is x is 50. Right? Now here it is here 50% of the values, right? It is 50%. This is 50% symmetrical. Right? Now 5% of the values are less than 5% of the values are less than what x values. So the smallest part, 5%, because here the less than word that indicates left hand side only because 5%. Right? If it is more than 50%, then we have to mark here. If it is a 55%, then that will come here. But only less than 5%, then 95% the values are going to be here. Right? So this is less than 5%. Now, this value. X A. Now here A is equal to 5%, that is 0.05. Right? Now this value we have to get. Right? Now the same thing we will mark in the Z because we have been going to use the table. So now this is equal to Z value 0. So now if it is this part is minus Z. Because in the left hand side values are left to the 0 always negative value. So it is minus ZA. This is 0.05. So this is equal to, because we have this also we have to find the first positive values. From the table only we can get the positive value. So this is equal to that 0 positive ZA. This is 0.05. But we know this area because we have to know this area. So from this one we have probability of that A greater than, sorry, probability of Z greater than ZA A is equal to 0.05. According to this diagram, we know probability of Z greater than ZA is equal to 0.05. So, now this area, from this we have probability of 0 less than ZA is equal to 0.5 minus 0.05, because half of the area is 0.5, right? So that is equal to 0.5. Right? Now you take the table. Now we have to search this where the 0.5 is located. That means which row and which column intersected at that point. 0.45 will be the value, right? So from the table, can you find where 0.45 is getting? There is a 0. In your table, take your table close to 0.45, right? There is a, if you are taking 1.6 row, right? When you are scan down the 1.6 row, there is a 0.4495 and also 0.4505. Either one of the value you can take, right? 0.0095 or 0.4505. The corresponding columns are 0.04 or 0.05. Now here I am taking the value 0.4505, right? So when probability of 0 less than Z less than 1.65 is equal to, according to this table, 0.4505 from the table, right? So by using these two things, now this is also approximately 0.4. Right? So from this we can say that probability of 0 less than Z less than ZA equal probability of 0 less than Z less than 1.65. So from this, ZA is equal to 1.6. Now first you note this one. I'm going to raise. Still we have a more calculation. Now we find ZA is equal to 1.65. So what is minus ZA? So minus ZA is equal to minus 1.65. But now we have to calculate the corresponding XA value. This value we have to calculate. Right? So we know that XA is equal to minus ZA is equal to X minus mu over sigma. Minus ZA is equal to X minus mu over sigma. So this is XA. Now the value is X minus ZA is equal to minus 1.65. This is corresponding XA minus mu 50 and sigma is equal to 4. Right? After calculating this one, now we have this area. So from this, I am writing here, XA is equal to, by manipulating this equation, XA is equal to minus 1.65 into 44 plus 50. That is equal to 20 6 point minus 6.60 plus 50, right? That is 50 minus 6.60, 44 44.4. So the X value, if you want to get 5% of the values are less than and but X value, X should be 44.40, right? Or 43.4, I think, right? What is the correct value? 44 or 43?
43, ma'am.
43, right? 43.4, right? 43.40. So now you look at how we are calculating. First, we have based on this given interpretation or given statement, we have to identify where the value located, right? So only less than 5%. So because of less than 5%, it is in the left tail, right? So this value, this is a probability of X less than XA. X less than XA is equal to 5%. That is the probability they give. X less than XA. What are the values? Less than XA. What are the X values? What percentage of X values less than XA? That is 5% they give that, right? So now according to that one, only we know the area probability, right? So now we are converting this probability in the Z form, right? So that is actually, this is minus Z. 0.05. But we know that the corresponding this one, the by symmetrical, we are taking the positive values. So always you keep your Z values with positive. So according to this diagram, probability of Z greater than ZA is equal to, now we given that probability of Z less than minus ZA is equal to 0.05. Right? So according to this symmetrical, this is equal to probability of Z greater than ZA also 0.5. now, then we are converting this area. This is equivalent to probability 0 to Z less than ZA equal to 0.5 minus 0.05, that is 5. Then we find from the table, we get the approximately the area value. When Z is equal to 1.65, we have area 0.4505. So this is approximately equal to 0.5. So this is equal to this one. This is 1.65. So from this, Z is equal to 1.6. But we need minus Z is equal to minus 1.6. Right? So when minus 1.65 is equal to XA minus 50 over 4, that is, so our value less than 50, that is we got 43.40. Right? So for the X values, don't mark the negative signs because we don't know whether it's a positive or negative. Just write XA. But when we are keeping this one in the standard normal, always the left side values we can put with the negative signs, right? Now for the next example. Mid 60% of the values are between but 2x values, right? Now they are asking the mid 60%. So probability of, we plot in the this is 50. It is 30%. It's 30%. Right? So one value is greater than 50, other value is less than 50. So now we gave that probability of XB less than X less than XA is equal to 30%. 0.30. Right? So now the corresponding Z diagram. You draw the corresponding Z diagram. This is X. It is plus ZA. But now it is a minus Z. It's 0. So only the symmetrically minus ZA. Probability of minus ZA less than Z less than ZA equals 0. Right? So now here we know that this is 0.15 and this area is 0.15. From this one, we can write probability of 0 less than Z less than ZA is equal to 0.15. Now you take the table where the 0.15 is located in the area, right? Where 0.15 is located. So from this one, if we are taking 0.15, first row, when that 0.0 row with the column 0.03 is 0.15, right? If we take the column 0.3 row, the row 0.3, if we take 0.15, it is 0.1480, that is close to 0.08. Then another is 0.1517. That both are, or you can take 0.08 or the 0.09. I am taking, it is approximating 0.08. So I am taking probability of, from the table, probability of 0 less than that, less than 0.3 7, sorry, 8, 0.38 is equal to 0.1480. It is approximately 0.15. Therefore, hence the probability of 0 less than Z less than ZA equals probability of 0 less than 0.38. From this, we have ZA is equal to 0.38. Right? Now, we have to get the corresponding x values because we have to find but 2 x values. Right? So, now we have to get the corresponding x values. So, when ZA is equal to 3.8, then 0.38 is equal to XA minus mu is 50 divided by, from this XA is equal to 4 into 0.38 plus 50, right? Calculate this value. Similarly, if minus ZA is equal to minus 0.38, then minus 0.38 equals XB minus 50 over 4. From this, you can calculate what is XB. From this equation, you can calculate the XB, right? So from this, you can get what are the 2 X values. You can get the 60% of the data. So the important thing when we are finding the x values, the appropriate area should be marked, right? Otherwise, you can't get the proper x values. So the first thing, read carefully and mark what are the corresponding area they are asked. Right? Then from that, you have to think about how we can calculate the corresponding value. So once you identify the area with the x random variable, normal variable, then convert the diagram to the standard normal case. For the standard normal case, for the values to the left 0, always you can mark with the negative signs. Right? Now we are coming to the next case. This one you take it as exercise, right? This is also exercise. Practice it. Right. Now, the example in the wording forms. Past data indicate that the time to download, this is the example we started when we are taking the continuous probability distribution. We started this example. Now we are coming to the example to solve the problems, right? That the banks expected probabilities, right? The past data indicate that the time to download a particular bank's website homepage is normally distributed with a mean of 7 seconds and a standard deviation of 2 seconds, right? And the probability that the download time will be less than 9 seconds, right? The probability that the download time will be more than 9 seconds. Similarly, there are some questions we have to calculate, right? So now we will go one by one. So here the mean mu is equal to 7 and the standard deviation is 2 seconds, right? According to that one. Now we are coming to the first example. Right. So first we will use the notation. Then only easily we can write the probability. So here the variable is time to download a particular bank's website homepage. Downloading time, right? So we are taking X. The time being download or download time. Downloading time. Bank's website homepage or bank's website. Right? Then they saw this. Then they gave this has a normal distribution. Right? Normally distributed. Then we have to give the two parameters mean of 7 and the standard deviation of 2. Yeah, where mu is equal to 7 and sigma is equal to 2. First, we have to calculate the probability that the download time will be less than 9. Probability of X less than 9 seconds. All the units are same, right? Seconds. And the deviation also seconds. So now this is equal to probability of, first we have to calculate the, if X less than 9, then corresponding Z is equal to x minus mu divided by sigma, that is equal to x is 9. If x is equal to 9, sorry, if x is equal to 9, then 9 minus mu 7 sigma 2, that is equal to 1. Right? Now the diagram. Now probability of x less than 9 is equal to probability of z less than 1. According to that, is 0, it is 1, that less than 1. So this the whole probability we have. So this is equal to 0.5. The left area left to the 0 is 0.5 plus probability of 0 less than z less than 1. So from the table 0.5 plus 0.3413, 0.3413, that is equal to 0.8413. So what is the interpretation of this one? The probability that means 84.13% of download times are 84.13% of downloading times are less than 9 seconds. Okay. 84.13% of downloading times are less than 9 seconds. Note this one. Right. So the next question. The probability that the download time will be more than 9 seconds. Now already we defined the notation. Now they are asking to calculate the probability. X greater than 9. So now in the previous part, we calculate probability of less than 9. But we know that probability of X less than 9 is equal to, from the part 1, 84.13. From part 1. So, but we know that the total probability is 1. So, probability of X greater than 9 is equal to 1 minus probability of X less than or equal to 9. Right? If we take this one, X 7, download time will be more than 9 seconds. This probability they are asking. Right? So now this X greater than 9 we can write as a 1 minus X less than or equal to is 1. But we know that this is equal to 1 minus Px less than 9. Because we know that for the continuous probability of x is equal to 9 approximately 0. Right? So this is equal to probability of x greater than or equal to 9 is equal to probability of x less than 9. Both are same. Right? So, but from the part 1, we have 1 minus 0.8413 less than 9 from part 1. So that is equal to 0.1587. So in the proportion, that is 50.87. Then what is the interpretation of this one? 15.87% of the download times are 15.87 percentage of the download times more than 9 seconds. Right? That means actually when we are taking the 100 downloading times, then 15 point nearly 16% or nearly 15.87% of the time. So 16 times are more than 9 seconds. Right? Next part. The probability that the download time will be under 7 seconds or over 9 seconds. Probability of x under 7. So less than 7 or x greater than 9. So these two are not intersected. So these are the mutually exclusive events. So it is probability of x greater than 7 plus probability of x greater than 9. But probability of x greater than 9 we already calculated from the previous part. This is equal to probability of x greater than 7 plus greater than 9, I think 0.1587 from the previous slide. 0.1587 from part 2. Now we have to calculate on the probability of x greater than 7. So now we have to calculate the corresponding z value, right? So if it is x less than 7. Thanks for the correction. It is x less than 7. It is also x less than 7. Sorry for the error. So if x less than 7, then when x is equal to 7, then z is equal to x minus mu over sigma. So that is 7 minus, now mu is equal to That is also 7. Seven divided by 2, that is 0. So now we have to probability of x less than 7 is equal to probability of z less than 0. Right? So from the diagram, that the mean value is 0. So we also z less than 0. This area we have to calculate. But without table, we can say that this area is 0.5. It is equal to 0.5. So now, therefore, probability of x less than 7, x greater than 9 is equal to 0.5 plus 0.1587, that is equal to 0.6587. That is equal to 65.87%. Similarly, you can write the interpretation. How we can write the interpretation? 65.87% of the downloading times are downloading times will be under 7 seconds or over 9 seconds. Right? The next example. The probability that the download time will be between 9 and 8, between 5 and 9 seconds. So that is probability of five less than x less than 9 seconds. Right? So there are two boundary values. When z is equal to 5, x equals 5, then z is equal to x minus mu over sigma. That is equal to, now here 5 minus 7 over 2, that is minus 1. Similarly, if x equals 9, that is equal to 9 minus 7 over 2, that is 1. So now we have to calculate the probability of 5 less than x less than 9 is equal to, now in terms of that, probability of minus 1 less than z less than 1. We have a diagram for this scenario. It is z, then the mean value 0, it is 1, minus 1. Right? So that is equal to probability of minus 1 less than z less than 0 plus probability of 0 less than z less than 1. That is equal to, this is symmetrically, negative value we have to write in the positive value. So this is also same as 0 less than z less than 1 plus probability of 0 less than z less than 1. So that is 2 times into probability of 0 less than z less than 1. So that is equal to 2 into probability 0.3413. That is 0.6826. So that means 68.26% of downloading times will be between 5 and 9 seconds. Right? Then for the next slide, the probability that the download time will be under 3.5 seconds. So now here the probability we have to calculate, probability of x less than 3.5. So only one boundary value. So when if x equals 3.5, then the corresponding z value that is equal to x minus mu. 3.5 minus mu 7 divided by 2, that is minus 3.5 divided by 2 minus 1. The probability of x less than 3.5 equals probability of z less than minus 1.7. If we have a diagram, minus 1.75, it is 0, it is z. This area we have. Right? So by symmetrically, this is same as probability of z greater than 1.75. So this one you can get probability of. Now only from the table, this area we can get. So this area is equal to 0.5 minus probability of 0 less than z less than 1.5. Right? And from the table, you can get the values. I leave it. The rest of the thing I leave it as a homework and you complete this. Right? And coming to the next slide. The same problem. Time in seconds will elapse before 10% of the downloads are complete. before 10 loading of the downloads are complete, what will be the time? Right? Before 10%. Only small amount of values, right? Before 10%. That means less than 10. This means, here this before means less than. What is the time will elapse? Less than 10% of the downloads times are complete. So if we mark this one, X. Your mean is 7. This area, they say 10%. X. A. Where A is equal to 10%. That is 0.1. They gave that probability of X less than XA is equal to 10. Now, if you draw the corresponding Z diagram, is minus ZA. 0.1. So this is also corresponding ZA bisymmetrical. It is 0.1. Right? So now this is equal to 0.1. If we are writing in the Z terms, probability of Z less than minus ZA. Right? This is equal to probability of Z greater than ZA bisymmetrical. Right? So now, but we know that this probability is 0.4 because this half of the probability is 0.5. So this is probability. Right? So in this diagram, we know that probability of hence probability of 0 less than Z less than Z A is equal to 1. Now if we search 0.1 in the table, right? From the table, we have probability of 0 less than Z less than, I think it's 1.28 is equal to 0.3997. This is approximately 0.4. Right? Therefore, ZA is equal to 1.28. But we need minus ZA. So minus ZA is equal to minus 1.8. Now we have to find the corresponding X value. Right? So, but minus ZA is equal to XA minus mu over 6. minus 1.28 equals XA minus mu 7 over sigma. From this XA is equal to 2 into minus 1.28 plus 7. That is 6 point. The time that elapses before 10% of the downloading times, right? The time that elapses before 10% of the downloading times are complete is 6.447. This is the answer. Time elapses. What is the time that elapses before 10% of the downloading times are complete? 6.4. So here before 10% of the time. Right. Suppose before it is a 60% of the time. Sorry, I think 4.44, right? Sorry for the errors. It's nearly, yes. 2 point is 3.56, right? So actually it is 4.4. 4.44 seconds, right? Thanks for the correction. Right. Now for the, suppose if it is a 60% of the, what is the time will elapse before 60% of the downloading times are complete, then actually for the 60%, if we are taking, if it's a 60%, then your diagram will in this manner. It's 7, and then 60% like here. It is XA. This is 60. Right? Then according to this, you have to calculate the value, right? Then 7 plus something you will get, right? So now we will move to the next example. The lower and the upper values of the download time include mid 95% of the downloading times. Mid 95%, right? The X is the downloading time. 7. Mid 95 means 95% A is equal to 95%. Then divided A by 2 is equal to 0.95. We are dividing 0.475. Right? So now this is 95% equal, right? Is XA is XC. This area is 95%. They say that probability of XB less than X less than XA is equal to 0.9. But symmetrically, if you take this standard normal distribution, this is equal to 0.9. ZA is minus ZA. 0.475. So this is equal to probability of minus ZA less than Z less than ZA. Right? So because of symmetrical, probability of zero less than Z less than ZA is equal to 0.95 divided 2, that is 0.475. Same here, right? Here is 0. Sorry, this is 0.475. Right? So altogether 0.95. Then from the table, probability of 0. Now you have to search for where 0.475 is located. Z less than ZA is equal to, I think it is 1.96. The table, probability of 0 less than Z less than 1.96 is equal to 0.475. Therefore, ZA is equal to 1.96. Right? Now we have to get the corresponding XA value. So, but ZA is equal to XA minus mu over sigma. 1.96 is equal to XA minus, now mu is equal to 7 and sigma is equal to 2. So from this, XA is equal to 2 into 1.96 minus 7. So that is equal to 3, sorry, plus 7, that is equal to 10.92. You check the answer, right? 10.92. Similarly, XB is equal to XB is equal to, it will be the minus, right? So minus 2 into 1.96 plus 7, that is equal to 7 minus 3.92 is 3.08, right? XA and XB. So the lower value for the mid 95% will be 3.08, and the upper value of the downloading time that includes 95% is 10.9. That means 95% of the downloading times will be between, now you can write the answer, 95% of the downloading times mid 95% of the downloading times will be between 3.08 seconds and 10.92 seconds. So 95% of the downloading times will be between 3.08 seconds and 10.92 seconds, right? So lower value 3.08, upper value 10.92. Right. And these two things are for the references. When the binomial distribution can be approximated by the normal distribution, right? What are the limiting values for n and p? If you want to calculate the binomial probabilities using the normal approximation, what the value will be n and what is the value will be p. Similarly, if you want to approximate the Poisson distribution to the normal distribution, then what will be the lambda value? These two things you have to calculate, and how we can get the mu and sigma for the binomial approximation and for the normal approximation, right? So here, the binomial and Poisson are the two discrete distribution. So how we can calculate the discrete probabilities using the normal approximations? That should be the reference. You have to, even in the notes, uploading notes are there. From that, you can get the idea, right? And also, you will be able to calculate the approximated probability for the binomial distribution, the normal approximated probability. Similarly, you will be able to calculate the normal approximated probabilities to the Poisson distribution. These two things are I am leaving as a references, right? So from some other websites or the notes uploaded, from that you have to get the idea. And this is the exercise, and this is also exercise. You practice it. Right. Any doubts? So next class, Wednesday morning, right? So Wednesday morning, 6:30 or maybe 7 o'clock, you will be informed through the LMS what will be the time. And the link also, tomorrow night, I will upload the link and the time, right? So the next Wednesday, we will start with the sampling distribution, right? So next Wednesday, you have the lectures at, sometimes you have exams. Anyway, you'll be ready, right? Be ready for the first exam with the 3 chapters, introduction and the graphical methods and the descriptive numerical measures. These 3 chapters will be included. MCQs and the calculations, MCQs mostly with the conceptual concepts, right? So the MCQs we will pick from my notes, and the notes uploaded, the reading materials I uploaded, that from that the MCQs will be picked, right? So carefully you read the uploaded reading material and my PowerPoint slides. And also the calculation part also, we pick the sums similar to the notes uploaded, my notes and the reading material uploaded. From this, we will pick the questions, right? So be ready for any day from this week, right? So even after, if you have an exam next Wednesday, then after the exam, you will have the lectures. Or first we will have the lectures, then you will have the exam, right? Whichever order will occur, it doesn't matter. So be ready from Wednesday onwards for the exam and for the lectures, right? So we will meet on Monday morning by 6:30, right? If you want to ask anything, you can ask. Otherwise, I'm going to end my meeting.
Thank you, ma'am.